Hello everyone, how are you? So welcome for a new everything everywhere, all with KDB Meetup. So today is a great day. So it's fantastic to have some familiar faces here and also some new ones. So thank you for coming. Thank you also for the people that is watching us online. So before we start, I'm going to give the micro to Leticia, who's going to introduce ourselves at the place where we are. So, Leticia, please.
Thank you. ¿Me traducís? ¿Creéis que...? Sí. Pues os hablo entonces español. Lo primero, bienvenidos y bienvenidas. Muchas gracias por estar hoy aquí. Estamos encantados de tener a Habla Computing, además de trabajando con nosotros haciendo este evento. Y voy a ser muy breve para dejaros todo el tiempo para la actividad que en realidad hoy os trae aquí, pero contaros algunas particularidades pues del espacio donde va a tener lugar, ¿no? Nosotros somos Triple, somos una firma de espacios de coworking y eventos ecológicos y aglutinamos una red importante de innovación ecosocial. ¿Esto por qué? Es porque el 90-95% de las empresas que trabajan con nosotros pertenecen al triple balance. No sé si estáis familiarizados con el término. Son empresas que tienen triple impacto, que es económico, social y medioambiental. Esto tiene que ver un poco con todo el concepto también del edificio, que era un antiguo taller de automoción, se hacían placas de automóviles, pero en 2020 se hizo la reforma íntegra del espacio por el estudio de arquitectura SAT, que también trabaja aquí con nosotros y que está especializado en arquitectura ecológica, sostenible y de eficacia energética. Y por resumir, allá donde miréis, material de las paredes, del suelo, la madera que es certificada, todo es ecológico, es sostenible. Estas máquinas tan estéticas que hay en todas las plantas del edificio están limpiando constantemente el aire. Somos el único espacio en Madrid que es CO2 nulo. Y bueno, funciona el edificio un poco a modo de passive house, pues por ventanas y demás, por aislamiento. Bueno, pues conseguimos eso que es tan importante, que la energía que menos gasta es la más sostenible, ¿no? Cuanto menos se gaste. Y alrededor de esto también hace 2 años empezamos un poquito nuestra trayectoria en proyectos que tiene que ver con empresa, emprendimiento, pero más enfocado a colectivos vulnerables, a los que están fuera un poco del ecosistema del emprendimiento y del privilegio. Si os interesa algo de esto y os resuena, pues aquí estamos encantados de recibir propuestas y de hablar de lo que necesitéis. Y nada, doy paso al acto, que es lo que hoy importa. Muchísimas gracias. Un dato práctico, el baño está abajo por el pasillo que habéis entrado, ¿vale?
Thank you a lot, Leticia. It's such a very cool place to be here. So, well, today we're going to have 2 exciting talks. Okay, so for the people that is new here, this meetup is related to KDB. So it's focused for KDB developers, but also for quants, for data scientists. So it's I think a very cool place to learn this language related to the practical uses of this. And the talks that we're going to have today, the first talk is going to be Umaima Bousdar from BBVA. Umaima has come from London, so he has just come from just for this meetup, and she's going to talk about neural networks and how you can implement this machine learning complex model in KDB using just a native queue. I think it's going to be a very good talk to see how this language is useful, and you can use it not only for data, only also for more complex models. And then we're going to have Jesús López, who is the usual host of this event. And Jesús works for Habla Computing, and he's going to tell us about the latest capabilities of KDB, how you can use KDB with AI, with Python, and so on. So a very different talk about the first one, but I think very useful as well. And that's all. At the end of the talk, of each talk, you can ask any questions by here. If you're the one that is present here, you can just raise your hand. And also for the people that is in the chat, you can write a question as well. And at the end of the meeting, the meetup, we will have some networking in the base floor. So stay, please. And we'll also have some drinks and food. So please stay. Without further ado, Okay. Also, this meetup has been sponsored by KX, so thanks a lot for them. Also, thanks for you for coming, so making this event possible. Thanks to you. So thanks. And so, without further ado, let's start. So let's welcome our first speaker, Umaima, please.
So can I put this somewhere in my body?
No sé si sé, la verdad.
It is. No? No. So, can you hear me well? Well, I don't know. People here, no. Yes, no? So I suppose. Esto está muy alto. Okay, let me share my screen. Okay. So, nice to meet you all. Thank you for coming. I am Umaima, people call me Uma here. I am data scientist at the Advanced Analytics and Algorithmic Trading team in BBVA Global Markets. Currently, I am based in London, but I used to work here in Madrid for 2 years now. Previously, I used to use KDB as a monitoring tool to build some metrics, more post-trade metrics, and more reporting things. But since I have been in the algorithmic trading team, I have moved to more advanced models, and that is the talk that I'm going to give today. So to present I'm going to sit. Sorry. To present the model, just to introduce you to the problem, no, that we want to solve. Imagine that we have a client that comes for us to request a price, no, and we have some features, feature A, B, C, and we want to know, given the price, which would be the probability of closing that request for quote, RFQ, let's call it. So what we are going to do is to build a model to predict that probability of closing. I mean, there are many ways of doing this, but using KDB, we have tried to explore building a neural network from scratch, because you know that KDB can be used using PyKX, or I don't know, you can use Python directly. But now we have tried to build the network from scratch. So the network from scratch, meaning from the data set, passing through the pre-processing, the training, and the evaluation. Everything is computed in KDB. So let's start. And here, so as I mentioned, we have this data set where we have different, let's call it, they are bonds, but let's call it securities, no, or RFQs. We have different RFQs with 3 features, and the target variable that we want to predict is if we win or not the RFQ, which would be just an integer 0, which 0 if we do not close, and 1 if we close it. So first thing we do here, it is to do the stratified train validation test split, which is very important in this case because we will show it later, but we have a very balanced data set because as a bank we receive a lot of RFQs, but we cannot close everything. So our percentage of positive cases, it is very, very high, very, very low, sorry. So what we have to assure is that when dividing into training and test, we maintain the percentage of one RFQ, the ratio of 1 RFQs. So how we do it? It is just identify all the indexes, all the indices that are 1 or 0. Then we select randomly the classes, and we define the percentage of train and validation and set as well. Then
can you connect the cable I didn't install because it's changing?
Sorry? Okay, I will try not to catch it a lot. So just, it is simple. From it is just selecting from the cases that we have 0, just the 60% we will assign to training, and we will select the same for test. What we get here finally, it is this split. We have the train, validation, and test. The number of RFQs that we have is almost 9,000, 3,000, and 6,000 for validation and test. And just to point out that the number of positive cases, it is very, very low, and it is 6%. This will take a lot of importance once we see the results of the neural network. Also here we have a standard scalar that it is just normalizing by the mean and the standard deviation. How we do this? I mean, this is quite simple. We compute the average mean and the standard deviation, and we just normalize. Important to do it just in test. Sorry, just in train. And then normalize validation and test with this. And finally, we get, it is just a simple test of which is the dimensions of our tables. And for the neural network, it is important as well to maintain the structure of matrix, because if not, it's going to fail the execution. So we have 3 features, and each of one, we have the 9,000 RFQs, and the same for test. And as the target variable, it is just a matrix or a single vector of the number of RFQs that we have. Okay, once we have this, we are going to see the implementation. Okay, so for those who are not familiarized with a neural network, it is just having a number. I mean, you have 3 features at first, no? So, well, 3 features, or the number of features that you have, no? So you have the features, then you create hidden layers in the middle with some weights for each one. Each hidden layer, you can select the activation that you have for that layer, which would try to introduce some nonlinearity features. Yeah, you have the input, the hidden layers, and the output. That in our case should be a layer of just 1 neuron, because we want to predict just 0 or 1. For doing all this process, we are going to use a binary cross entropy loss, and how it is going to work, we will explain it later, no? But we will execute the binary cross entropy, and then we do the back propagation and keep on optimizing until we get to the best solution. So just some implementation. Yeah, I have to mention one thing here. It is that although some of the code was done completely by us, the initial approach was done by Nick Saris, which posted a free repo where he built the neural network for the MNIST dataset, which is a handwritten dataset. So some of the code it is from him. Okay, so we have activation functions. We have the sigmoid, the sigmoid, which is the derivative of the sigmoid, and this is the implementation. It is just using a native KDB language. The logs function, which is in the case of a binary classification problem, we have it is just the log likelihood. And also we have developed a weighted log loss function, because as you know, the data set is very imbalanced. So probably we will need to put more weight to failing in the case of predicting positives. So this is the implementation. It is just, just responding to the formula. And for the weighted, we added the weight of 1 and 0. These are some of the utils that we will need to compute the neural network. The forward propagation, because we will have a forward propagation that will be multiplying the inputs or the transformed inputs by the weights and adding the bias. This is the PNN would get the probability. So these are the main two functions, no? The forward propagation and the PNN, which at the end, the output of the neural network would be a probability between 0 and 1. And if the probability is higher than 0.5, we will classify the RFQ as 1, or the target variable as 1. And if not, we will assign a 0. So these are some utils. Also, as you know, neural networks in Python, neural networks has a lot of utils and a lot of different ways of doing things. We have implemented some of them, and it is just a framework, but you can add whatever you want. In this case, we added a scheduled learning rate, which would be when you try to optimize the theta or the weights of your neurons. You can just assign a constant variable, a constant learning rate, but you can also vary your learning rate as you progress in your iterations. So this is the way of, there are multiple ways, but we have decided to implement this because we saw that it worked. And this is the thing. And here is the most important function, which is the cost gradient function. I have added here. I don't know if I should make it bigger or you see it correctly, but no, if I put it bigger, it does not change much. So this is the core of the neural network. Here we are going to do all the optimizations to get the final, because what we need finally to get is the weights of the neurons, no? The weights. So this is the function that is going to compute the optimization. Imagine that you have in each iteration you have a set of thetas or zetas, which are the weights, and you would do first is forward propagate. No, you have the inputs, your initial weights, and you get the prediction, the P. Once you get the prediction, you can do two things. You have to do two things. One is to compute the error, which would be first classify, and then make the difference between your truth variable and your predicted variable. And also you have to compute the cost, which is the gradient cost. Well, no. First you have to do the output, and then once you have the error at the end, you have to back propagate the error to the beginning. How to do this? It is just if you have done the forward propagation for the backward propagation, what you have to do is use transpose, and for the activations that you used, you have to use the derivative, because it is going to apply the rule chain, the chain rule of derivation. So once you have all the errors propagated through the neurons, you have to compute the gradients, which would be how each of the neurons affect the final output. And once you have that, you get you update the data. No. Okay, these are the formula, and I will explain a little bit the code of KDB or KX, which would be you first take the zetas from the previous one. Now here, what you are going to do is the forward. As I mentioned, this is the main this is the function that computes the forward propagation. Once you have it, you use this to compute the probabilities, and with the second one, you compute the error, which would be the J. It is just a difference between the I, and the I, which is the target variable, and your predictions. Now you have to prepare the network to use the derivative. Now you are saying, now I'm going to use the derivative with the HGov that we will, when we use the network, we will explain that. And once you have the back propagation, you compute the gradients. Okay. And yeah, the output of the network will be the gradients and the loss. Okay. Here we have another implementation that uses the weighted loss log function. I have just separated them, and yeah, I just separated them because I wanted to maintain as I was testing, I wanted to maintain the original code. And yeah, the training loop. The training loop is something, it is quite easy, no? Well, we have implemented different training loops, but mainly what it does is, okay, we start from an initial set thetas, and what we are going to do is compute the cost and gradient, update the thetas, and check if our stopping, we are going to configure the neural network to stop through different ways, and we check in every iteration if it fulfills the rules for stopping, and once it is, we fulfill them, then you have the training model. Which are the implementations that we have done? First, the regular one, which is the batch gradient descent. We are going to use a constant learning rate, and it is going to stop by tolerance or by iterations. Then the scheduled learning rate, it is just the same as the previous one, but using a variable learning rate. The mini batch stochastic gradient descent, this is to not train all the data set in every iteration. It would split into mini batches, and in every iteration we will use a different batch. The early stopping, it is just to introduce the validation subset, and what we are going to do is stop not only if we fulfill the tolerance or if we pass the number of maximum iterations. We are going to compute a cost in validation, and if we see that cost does not increase, because the training cost always decreases, but at some point we will start overfitting. So what we have implemented is the validation cost, so that when we observe that the validation does not increase, does not decrease anymore, we are going to stop. Yeah, the weighted loss, we discussed it, and it is just using the weighted loss, and also weighted loss with early stopping. Okay, I mean, this is a bunch of code. I mean, I think we can share the repo, no? But let's explain a little bit the first one, which is quite simple. The train. So as we mentioned, we perform the cost gradient, the initial iteration, and while we have not reached the maximum number of iterations, we are going to take the theta. This is the main line of code. Here, what we are going to do is, okay, we have the theta. The gradient cost has told us to move through a direction. Let's move that and see if the error does improve or not. Then we compute the condition, the tolerance condition, and if we do it, just end. And the other iterations are just the other methods are just simple changes in this function. Okay, so the execution. So let's see the execution. So how do we use the network? So first, you define the topology of the network. Imagine that you have 3 inputs. So the 3 features that we have a single neuron output because we just want to predict one, and then in this case we have selected just the one hidden layer, but the code is prepared for more layers. So one hidden layer, and we define the neurons here. Then you have to initiate the thetas, which would be our weights. In this case, I have initialized them as 0. And here you have to configure how the structure of your neural network is going to be. You define here that for the hidden layers, you want to use the sigmoid activation. For the G, which would be the back propagation, we are going to use the derivative of the sigmoid activation. For the output, you define as well the sigmoid, and as the loss log function, you are going to use the log logs. And then just as simple as you define the number of iterations. I don't know if you see it right, but I can make it bigger. So you define the number of iterations, the tolerance, the learning rate, the topology, the configuration, the target, the training, and the initial thetas. Then, once you train it, we have here the prediction in test and in train, the probabilities. So the probability of train and test. And we have built as well a function that performs all the metrics that we wanted to check to see if the network does work or not. Well, it is here. We can go pass quickly around it. Validation. Let's go quickly because they are common metrics that you probably know. Well, the accuracy and precision. Accuracy out of everything, which are the positive cases. Precision out of the positive, which one were truly positive. The average precision. This one, we studied that it worked better for imbalanced data sets. And it just combines precision and recall. The area under the curve, which tries to check if your classification does it better than a dummy classification of 0.5. If you are over the rate, the 0.5 classification performance, you are better in theory. The calibration analysis, here it is a metric that it is very used in our team. The calibration analysis or calibration plot. What we are going to do there is over all the probability of over all the predictions, we are going to make buckets of 10%, for example. So we will have we will group all the RFQs that have predicted probability of closing between 0 and 10%. Then we will analyze which is the real hit rate on that bucket. So in theory, if our model was perfect, what we will get is, in the first bucket, our probability of closing, our hit rate would be 5%, more or less, no? Between 0 and 10. Over the next bucket, 10, 20, we will have almost 15%, no? Because we predicted that those RFQs had probability of closing between 10 and 20. And using this calibration plot, we have the Breyer score, it is just a number to translate into a single metric, this calibration plot. So against the ideal model, we will check which is our performance. Yeah. And what we have here, so execution, we have here what is the output, no? This would be the weights of our neurons. This would be the cost. The reason why it stopped, because if we are stopping because of iterations, probably the network has not converged. And it happened a lot. I mean, every time we develop a new training loop, it could happen that the network does not converge, and you have to look why. Which is the number of epochs, which is the number of iterations, the model, the accuracy, the train, and everything. Okay, we are going to, I have some graphs that we can review, but just to show you a little bit of why we pass from one model to the other, because we keep on observing some things and we try to enhance them. So what we saw here is that we have the network converge with 62,000 number of iterations, which is quite a lot. So we decided, okay, so let's try to reduce the number of iterations, no? However, over everything, let's see the base model. We see an accuracy of 95 or 94, but just take into account that almost predicting 0, if you predict the baseline, if you predict everything 0, we saw 60% of hit rate. So if you predict everything 0, you would have an accuracy of 94. So the accuracy is not a good metric for evaluating our performance. In precision, in train, we have a 69%, which is not bad, 68%, and an area under the curve of 91, which is quite a good area under the curve. So what we did, okay, okay, we will go quickly. So here what we saw was that we have a lot of iterations. Let's try to reduce the number of iterations. Let's use a learning rate, a faster learning rate. We implemented the scheduled learning rate, and we saw here that the number of iterations run reduced to 18,000. So, and if we check the performance was not very downgraded. Then we saw that probably we were overfitting. So let's use the early stopping to not overfit in validation and then not overfit in test. So we perform the early stopping, and then the weighted loss function. As we are running out of time, I'm going to pass directly to the graphs to show them a little bit. Let's go through the graphs. Well, I it was expected to. I was trying to do this in KDB Insights, but as we are running out of time, I will show you. This is the cost. This is the cost. If I can. Well, this is the cost of the basic. No, this is the cost of the basic neural network against the scheduled learning rate. We see that just with a few iterations, the scheduled learning rate optimizes much better, optimizes better the performance, and it is. I mean, it does need less than the half of the iterations. And also, if we compare the cost of using validation in the early stopping, we see that the basic one, which is the dark blue one, would keep on optimizing, whilst the early stopping stopped in 25,000 iterations because the cost invalidation was not improving. And yeah, some of the, let's go directly through. It is not here. Let's execute. Let's execute this. Okay. It is here. Let's go through some of them. Let's use the one that has everything to work through it. So these are the 5 models that we have trained. In accuracy, as we have discussed, it is very good, but it does not count in this case. In terms of precision, we see that the one that performs better is the early stopping, because we have tried not to overfit. As trying not to overfit, the precision in test has improved. However, the one that we were expecting to have better performance, which was the weighted loss, because we were penalizing, classifying wrongly the positive cases, we expected to have better precision, but in this case, it has not worked. And also, well, we had another model, but we have run out of time. And this model, performed worse than the rest. In terms of the ROC curve and area under the curve, they all have similar values. If you see here, this is the baseline where it is a knife. So maybe the scheduled learning rate model performs a little bit better, but however, the area under the curve, it is quite similar for all of them. And for the calibration plot, which as I mentioned, this is out of all the RFQs that we predicted that we were going to close between 0 and 10%, which is the real number that we closed. They all obtain similar, not similar, but when then the neural network tries to fit any of the buckets, it performs worse in other of the buckets. For example, this one here, for the bucket of predicting 75% of closing, so we are going to close with a 75%. It does not do it right, but it is because for the lower probabilities, when it does predict that we are not going to close, it overfits them. So it says more commonly or more frequently that we are going to close. So over all of them, I think that the early stopping would be the best one that we have found. But just as I mentioned, this is creating a framework of doing or creating a neural network from scratch in KDB, everything. So I think that is all from my side. I don't know if...
Any questions?
This is my boss.
¿Si me responde yo?
Ya, pero... bueno. Espera, tú, espera.
No.
So what would you say is the advantage of doing this from scratch in KDB instead of using Python libraries?
Yeah. Well, this is also something that... Well, give me a sec. Yeah, this is also something that when you, in theory, I mean, when you proposed to me to create this in KDB, I was really excited to try to build it from scratch. So this was one of the main things why we decided it, but also because we want to control the network from inside. You can use kdb-x to do it, but what we want to do now and as future work, what we are going to try is to modify the network from the inside, which would be, for example, to convert the network into monotonically increasing, or I don't know. We want to have the whole control of the network and to change whatever we want. And with that, I mean, you can do it in Python, but as we have all our environment in KDB, if you have all your environment in KDB and you want to have a control on everything, it is the neural network does. It is this is the way we thought it should be a good way. So.
Okay, actually, there is also now, I think, in the offer in KDB to have a GPU acceleration as well. So maybe it's something we can try.
Yeah.
For free.
Yeah.
If KDB is listening. Okay.
Okay. Any other question? Okay.
Okay. So
Jeffrey.
leave the stage to the next one.
Thanks a lot, Uma.
How I do?
Yeah, so now let's go on.
Pero seguro que salga en Chepa. Salía en Chepa. Sí. Y ha estado bien de tiempo, tío. Mira que va a ir cortísima de tiempo. Sí. Dale, literario. Dale ahí. ¿Has visto? Sí, claro. Sale tú. Sale. Sí. Al final he creado una buena infraestructura de música. Allí, o sea, te final tenía nada. O sea, no nada, tenía tal, pero no lo tenía así.
Well, hello everyone. I'm Jesús. Thank you very much for being here. And today, well, this is a talk in collaboration with Pablo Lobato and Miguel Aredo. We have heard a lot in this thing. So this is going to be about our experience in the last 6 months working with. I don't have a mic. ¿Estamos? Okay, so sorry. As I was saying, this is going to be about our experience working with KDB in the last 6 months. So what was different in these 6 months? There are two things. First of all, is that we've been using kdb-x. And the second thing is that for the first time, I've been embracing artificial intelligence tools in order to develop in KX in a real project in BBVA with Javier, Manuel, and the rest of the team. So first of all, so who knows what is kdb-x? Okay, so I think that this is the first thing that we should to discuss. So kdb-x, according to KX, is the next generation of the KDB ecosystem for real-time, data-intensive, and artificial intelligence-driven applications at scale. So for me, basically, this is the old cube and KDB with the good performance, with the awesome performance. We also have the same architecture. We have the thick architecture, but we have some new exciting features that we are going to show today. Some of them. There are many things in kdb-x, but today we are going to show some of the things that we think that are interesting. So we need a domain. I'm not going to use the real project. I'm going to do something completely different. We are going to discuss to use OpenTelemetry as a domain. So what is OpenTelemetry? OpenTelemetry, according to the website, is a framework for observability. Okay, so what does this mean? This means basically that this is a framework, an open format, so we can integrate different languages, different frameworks, and we can unify the telemetry of all of them in a single framework. So what I think is really cool about this OpenTelemetry thing is that they have a demo, which is this one, is a GitHub repo. And let me start everything. Okay, it has many things. So in a sense, this demo is an astronomy shop. They sell telescopes, they sell lenses. And the good thing is that we can provoke failures. So we can later monitor them. Okay, so we are going to see it. It's going to be more easy. Once this starts, okay, we have it. Okay, so this is our shop of telescopes. This is a fake shop, of course. And we can go shopping, and we can say, okay, I want to buy this telescope. I'm going to add it to the cart, to the shopper cart, and I can place an order. So I buy it. Okay, so I'm buying this telescope. But we can also, for example, here, we can go here and we can tune the behavior of the application. And I can say, okay, I want you to always to failure when we are going to pay. So we're going to have a rate of 100% of failure when we pay. So in this case, we continue shopping. We buy this lens, for example, we add to the cart. And now, if I place an order, this is not working. Okay, because we are provoking that all the payments they are going to fail. Okay, so we can come back here. We come back to the normal behavior, and we can say, okay, now the place order should work. Okay, this is easy. This is a demo for. We have different services. We have an advertisement service. We have a recommendation service. We have many things, many microservices implemented in different languages, and they are all sending the telemetry using the same framework. This is the main point of all of this. So you can see here, we have this collector. We have the microservices. We have the collector, which is collecting all the information and forwarding it to Grafana and Jagger or these monitoring tools. For example, we can show here that okay, this is a dashboard of Grafana because the application is sending information to Grafana, so you can visualize it. Okay, so the demo is really complete. But so what is our objective today? Our objective is to add kdb-x as an additional destination for this telemetry. Okay, so we have Grafana, we have Jagger, but now we are going to connect it also to kdb-x. So basically, we are going to follow this architecture, and this is what we are going to implement today. So there are many components. Don't worry, we are going to introduce them as we go. But in a sense, the collector is going to send information to this feed handler. Then we have all the architecture, and we are going to establish two main objectives. The first one is going to implement this monitoring dashboard. We want to identify when we have a payment failure, and we want to show it in this dashboard. And second one, we are going to expose the whole system, the whole functionality, to an agentic ecosystem. Okay, so we want via an MCP server, we are going to expose it to other agents so they can interact with this system. They can ask questions to what is the health, how is the health, how is the monitoring of the system doing. Okay, is it clear, more or less? Yeah. Okay, so the first thing that we have to decide is the development environment. As you saw, Umaima was using Visual Studio Code, but I want to say that I am a vintage developer, not an old developer. So I'm going to use Vim, which is this editor here. And this is a GitHub repo. Okay, as you can see, this is the official demo from OpenTelemetry. And my contribution here was to add this kdb-x folder, so we can integrate the kdb-x as a destination for the telemetry. So this is just an extension. This is not official. Okay, this is a branch of myself. And the point, the next thing to decide is if we wanted to use a coding assistant or not. This was a decision in the BBVA project. I heard of many people that say that they didn't want to use this thing. Other people is on the other opposite of the spectrum. They want to use it for absolutely everything. But I had Alfonso, he's not here, but my workmate, and he said to me, you have to use Cloud Code because it's going to be really interesting. So I think it's really powerful. It is worth, but I think that you should use it with care. We are going to come back later on to this discussion, but yeah, I think it's really powerful, but it's kind of dangerous. So, okay, so let's start implementing these things. Microservices, sending telemetry to the collector. The collector is going to send information to this feed handler. The feed handler is going to forward to the ticker plant, and then it's going to forward also to the real-time database. So what is each of these components? The feed handler is basically the adaptation of the data feed to our tick architecture, the typical architecture in KDB. So this is going to be a Python thing. We are going to show it now. Then we have the ticker plant. The ticker plant is the core of the tick architecture. Is the one that forwards all the ticks to the different subscribers, to the different components. And this is the most standard component, which is the real-time database. This is a subscriber which is going to collect everything and is going to keep all the information that the ticker plant sends in the form of tables. Okay? So let's go to the code. Let me show you a little bit of the sorry. Oh dear. Okay, this is the feed handler. I'm not going to show the details, but I want you to focus on this part here. You can see that we are importing this library, which is PyKX, the one that adapts Python to Q and Q to Python. And then we are going to connect to the ticker plant using this sync Q connection. This connection is an IPC connection, inter-process communication, and it's a lightweight communication that the tick architecture uses in order to be really fast and to send the information, to send the data from one component to the other. So this is the most important thing. We are using PyKX because it's going to be a quite important tool in this demo. So we are going to use it to forward the data, the ticks, to the ticker plant. So now, well, the ticker plant is a standard thing. I don't want to show it. Also, the same with the RDB, real-time database. But here again, the code is a standard. The code, you can copy paste it. This is the vanilla tick architecture, but the most important thing perhaps is this one, where we say that we want to subscribe, and this backtick are the empty symbol, and we are basically saying, I want to subscribe to all the tables, and I want you to give me all the symbols in those tables. So give me everything, basically. Okay. So we have the fit handler with Python, by KDB-x. We have the real-time database, and I would like to check that this is getting data. This is one of the first things that I like to do when I'm creating a tick architecture from scratch. So we want to establish that all the communication until here is working. So we need to run it. Wait, sorry. We need a running environment. And the problem in our company is that one person uses Mac, like myself. We have another person which is using Windows. We have Linux users. And we have different people that is going to execute the same system locally. So the problem is that if you rely on local installations, the problem is that you are going to find many problems, one with the license, another one with KDB-x, another one with another tool. We saw this in our work, so this is kind of frustrating. So what was our solution here? Well, it was easy. It was to embrace Docker as a homogenizing component. Okay, this is the piece that let us be homogeneous when running the information, the code. And the good news is that in the past, in order to install KDB and Q, you need to you needed to submit a form, then they send you the binaries. But now we have a developer portal, and we can connect this. We can connect it to this Docker file. Sorry. And here in the Docker file, you can say, okay, use this typical Python image with Linux, then install by KDB-x, whatever, and then install KDB-x. So this is simple. This is something which is naive, but this turns out to be really, really important because we can create Docker image and we can run it everywhere, locally in a cloud environment, whatever you need. So now we have the way to run our system. So the next step is to validate that our real-time database and that our components are actually getting the information. So we are going to rely here on, we are going to use a Jupyter Lab that we have installed in the Docker file here, this way here. And now we are going to open the dashboard. Sorry, on this one. Okay, so we can import KDB-x. We can simply run this to check that everything is going okay. And now we can use a Q magic command, this one, and we can say, okay, this is going to be Q code. This is fine because you open a process in Q, but the really good thing of this Jupyter with KDB-x is when you start to add these parameters. For example, here, we are saying that we want to connect to the port 5010, which is the ticket plan. We are checking that there are subscribers there. We want to check that the RDB, the real-time database, has tables. We want to check that one of these tables is populated. We can use it to check that everything is running fine. And well, also, not only we can, this is not even, the good thing here is that we can replace code on the fly. So for example, if we have a function in this component and this function is failing, the good thing is that we can replace it on the fly and we can say, okay, no, I want that the new function is this one. So you don't need to restart the machine. You can debug really fast and you can get the code here and you can change it and you can replace, and it's really useful for developing. So okay, so where are we now? Okay, we have Jupyter Lab. And now we are going to go to this monitoring service. Okay, so this is basically the first component that we are going to develop. Well, also the fit handler. But this component is the one where we are going to implement the monitoring logic. This is where we are going to check that the health of the system is correct. So I don't want to focus on the logic here, but I want to emphasize another aspect, which is this one. Okay, what is this? What are we doing here? Yeah.
Starting the log or setting up the log?
We are starting the log, but what is this use? What is this? What is different from other KDB code?
It's a module, right?
It's a module, right? This is like this use is like an import in Python. This is like a way to bring in a package, and we are using it right here. So in this case, we are using the kx log, which is a standard library from KDB. But also, once you have this idea of modules, you can create your own libraries, and you can actually create it in a very simple way. For example, in the case of this project, we created this library, which is called Qt. It's really simple. Here we have several primitives, which are straightforward. Something has to be equal to another thing, not equal. This has to be true. This expression has to be false. This value has to be near to another one. And then at the end, we have this export. And this export, I'm going to. Okay, so this export is the way we tell it that this module is exporting this functionality. So when you use it in another project, you are able to use these functions. So you don't need now to copy the code and to put it in your repository, but instead you download it to a known folder, which is Docker file. Sorry. So you can basically copy you can clone this repo to the qhome in the mod directory, the module directory, and then you have it available for your codes. So this is really nice, because for the first time we have the ability to import code, and you have the ability to share your libraries, which is something which is not really frequent in KDB. So okay, so we have the service, we have modules. And now we are going to solve this dashboard. Okay, this is going to be something simple. The idea here is that we have this dashboard. Okay, you can see that it's updating in real time, and we are going to enable the payment failure. And if it works, because sometimes it doesn't, we are going to start to see some failures in this payment part. Okay, so this is a dashboard from KX, and this is basically, it has a data source connecting to the other system. Let me update it. Okay, 1 second. We are going to add. Okay, I don't know. I tested before the event and it's not working here. I don't know if it's something with the connection. Okay, this is working now. Okay, so we can see that we have failures in the advertisement and the front-end proxy, and I think that soon it's going to start to populate the payment. Or well, I don't know what to do. But well, basically, this is a simple dashboard, and the idea here is that we can check that the health of the system is okay. So. What is a thing that we discover in this project? That KX dashboards are basically JSON files. So the good thing of a JSON file is that you can version it, and you have a version of the dashboard which is in correspondence with your code. This is really nice, because in the past we had to do many changes, and basically the last version you had to do some workarounds in order to have it working. So with the JSON file, we can version it. You can use your coding agent in order to make modifications. But the problem is that you have a lot of conflicts when you are working with several people. So what we did here is that we install a politic of doing a sequential change. So if we have to change the dashboard, we have to plan it, and we have to do it one, then the other person, and the other person. And well, Miguel and Pablo, they know a lot about the situation. So next thing. Okay, next thing is the MCP server. Who knows what is MCP? What can you tell me about that? Edu. What is?
It's a protocol to connect to several LLMs and interact with it.
Okay, perfect. It's a protocol that you can use to expose some tools, some prompts to other agentic to other agents or to an LLM, so you can interact with it. So the implementation of this is really easy. Okay, basically, an MCP is about using these decorators, MCP tool, and you say, okay, this is the get health, this is the documentation, this is what this function does, and this is the way we get this health. And here we can see that again, this is a sync queue connection. So this is also, we are also using kdb-x in order to implement the MCP. The MCP is just that. We establish a connection, we get the code for this tool from the MCP, and just that's all. So, for example, we can connect it to our coding assistant. We connect, get the health of the system. Okay, this is asking me if it's possible to call this tool from the MCP. And if you say yes, then it takes some seconds. Okay, it says all devices, all services are working fine. They are okay, the recommendation, the product, whatever. So my point here is that this cloud code knows a lot about the code. He knows about what you want to do. And also he knows how to interact with the system running. Okay, so this is really important because once you have developed it, you can run it and you can say, okay, test that everything is going fine. And this is really practical because you can see if the health is going okay. You can check if you can do integration testing. You can say, okay, call this tool, and if this is working, then call another tool and then call another one. So it has a lot of information, and it can help. It can be really helpful in order to make these scenarios working. Okay, so the MCP is not only to expose the system to for production, but I think that it's also a really good complement while developing. So finally, we have this last part, which is using the MCP to connect to an agent mesh. An agent mesh in this context is like a broker where you have different agents which are connecting and they are interacting one with another, and basically they are cooperating to get to fulfill some objective. So I'm going to start the agent mesh. 1 second. Someone. Okay. Okay, so Solace is running. Okay, this is of course quite complex, but this was a huge simplification. But basically, what you get is something like this. This is the chat of Solace, and now you can see that we have 2 agents connected, which are the KDB Plus agent, the OpenTelemetry agent, and we also have a weather agent. And also, this is a central piece, which is the orchestrator. The orchestrator basically is the one that plans what they have to do, and he also delegates the task to the most appropriate agent for the task. So, for example, we are going to see this is where things are going to start failing, of course. So, okay, so what is the weather in Madrid today? If it's over 25 or 23 degrees, then check the health of the servers. Fingers crossed. Yeah. Okay. Okay, so here you can see that this is what the orchestrator is deciding. First, we are going to get the current weather, and then if the temperature is over 23, supposedly we are going to see the health of the system. So let's wait some seconds. Okay. Yeah, it's taking too long. I don't know if the connection here is blocking something. Okay, the temperature in Madrid is currently 28. So we are going to check the server health. So, well, in a sense, the orchestrator is putting together is making the weather and the health monitoring system cooperate, and we are going to see this thing if it works eventually. Okay, what is going on? Okay, it's calling it. I think we are close to an end. Okay, so you can see that, of course, the weather is over 28, and the server has detected that the payment and the checkout are failing because we made this failure. Also, the good thing about Solace Agent Mesh, for example, is that we can connect it to Slack or to whatever. Here you can see that we have some interactions, and yesterday I was trying to see what was the health of the system making some services fail. And well, you can see that this is basically the same thing that we are looking at the Solace UI, but you can connect it to other tools. This is a gateway to Slack, but I think that you can connect it to MS Teams and other systems like that. I think that this is quite cool. So, okay, we have all the parts of our system, and we have seen that we have this demo. We extended it with the tick architecture. We created this feed handler. We are forwarding the data to the tick architecture, ticker plan, real-time database, monitoring service. We also were able to check that everything was fine using Jupyter. PyKX is an important piece here. PyKX is also here and here, so it turns out to be really, really relevant in this interaction with external systems. We saw a simple dashboard. You can do many things with dashboards. This is just a basic example. And well, finally, you can use the MCP server for your coding agent. I think this is a good practice. I think it's really, really powerful to have this connection between developing and interacting with the running system. And finally, you can expose it to other systems, to other platforms. So your MCP is something, a tool that whatever LLM could use. So, conclusions. KDB-x is the Q and KDB performance plus some extensions, some new features that I think they are really nice. PyKX is crucial. I think that modules are also quite relevant because we have the possibility of sharing repos with other people in an easy way. I think that this is a big step. There are still lacking some things, but I think that this is in a good direction. The MCP is really nice, the model context protocol, because you can use it in different scenarios, even connected to an agent ecosystems. So, coming back to the discussion that we said at the beginning about using cloud code or not. So, how should we use agents today? Okay, so I have no fucking idea, sorry, about that, because it's I don't have an answer for that. It's I think that it depends on you. But for example, in my case, I want to, at this time, I think that learning is important. So the way to learn is not to delegate all the work to to artificial intelligence. I think that you should never delegate thinking. What does this mean? That the design has to be yours. The design has to be your own thing. This is your product. You shouldn't let the LLM to decide what are the things that it has to implement. Because, for example, I remember one day I was doing the experiment to say, okay, I'm going to send you the issue to see what you are going to do. And it created something really weird. It more or less was functional, but it was so difficult to interact with it. I had to debug one thing, and it took me like the whole day. So at the end, my conclusion was that this is not my design. This is not the way I think. So I think that you should, before asking the AI what to do, you should know what you want to achieve. So once you know that, more or less, you can discuss it. You can discuss alternatives with LLM, because I think that this is really, really helpful. Okay, this is what I want to do. What do you think about that? Do you find there are other alternatives? Do you think that there are other things that we can use in order to improve it? So I think that this was the right way to learn in my case. For the case of Q and KDB, we don't have the code base of Python. So I think that this is a small community. And the problem is that it doesn't work very well. In the case of Cloud Code, this is the only thing that I was using. And the problem is that I think that sometimes it doesn't capture the essence of array programming. I think that it doesn't understand what it has to do. And sometimes it creates really weird Pythonic code. It works, but it feels weird. It's not the natural way to use Q. But if you tell him more or less what to do, you say, okay, if you have this situation, I prefer you to use an each left or each right, or you should use here a functional select. Then it learns in this session, and he's able to produce to produce more or less the good results. And also it understands what are you doing. When you make a change, he says, okay, okay, this is fine. I think that this is correct. And it understands what is your intention and what is your way of thinking. And okay, so I think that it's important to review every single line of code, but you can relax on peripheral tasks. For example, testing. I think that in this case, I created hundreds of tests because it works very, very well. I told him, okay, you can, this is the tool, this is the thing that I want to test, I'm going to add this test, but what do you think? How could you extend this suite with new functionality? So I think that it worked very well in this part. So this is what I think today, but it might change tomorrow. Why? Because I could see that if you give the knowledge of the architecture patterns, if you give the knowledge of the domain, and if you supply the knowledge of the technology, it works very well. Of course, nowadays we have limitations with the context, we have limitations with the technology, but I think that in the future we are going to be able to overcome them. So I think that nowadays the challenge is to know how to collect this knowledge, how to structure it, and how to use it in an efficient way. I think that this is in an efficient and secure way. I think that this is the challenge that we are going to face in the next years. So Juanma here is working in this initiative of knowledge-driven software development. So I have no idea what he's doing, but I think that you can have a good conversation with him at the networking. So yeah, that's all basically. So thank you very much.
Well, thank you, Jesús. Any questions?
Thanks, very interesting, Jesus. One question: if you didn't have KDB-x, it was the previous KDB. What would be the challenge to implement this, or what was the advantage of using KDB-x specifically?
In this case, PyKX and the modules. I think.
Is it better integrated with KDB-x, PyKX, because PyKX existed before the KDB-x?
It existed, but I don't know. Sometimes there was this conflict with embed-q, embed-py, and I think that this is the official way of using it. It feels to me that it's PyKX also inside, probably. But well, also beyond PyKX, I think this is important. But I think that you have PyKX available in another version. you could implement an MCP, for example. But modules is also a difference. You can use, you can export. And
this keyword use is from KDB-x.
The use is from
okay,
KDB-x.
that's what I didn't know.
The use and export is from KDB-x. So this is the way. Because in the previous versions, you have the namespace. You can import it, but at the end you have conflicts with the names. And this is a clear way of
so they bring from Python somehow. So they try to bring some concepts from Python.
Yeah, it's the import from Python and from other languages. Yeah.
Okay.
And also we couldn't cover that, but for example, you have the HNSW, the hierarchical navigable smart worlds. You have libraries for doing many things, AI, for vector searching, for other things. I don't know. I haven't explored them, but there are more official libraries available for use.
And in performance, is the same? Works better?
The performance, I would say, is the same. I think that this is a new package with new extensions, but I think that. I'm not sure about that, but I think it feels like it's everything the same. You run the tick architecture and you are under 1 millisecond, so it's fast. It's very fast.
Okay, cool. Thank you.
Hi, Jesús. You said at the beginning that you are a vintage, not old programmer, right? But let's suppose that you're not.
Okay.
So do you think that the system could hugely benefit of having some kind of, I won't call it wrapper, but let's say something like an abstraction layer just to make easier the creation of the basic parts of the system? I mean, ticker plan, RDB, these kind of things on a more visual way instead of having to run the specific port or host commands. I'm talking about something kind of controlling the system.
I think that Christian told me about the X-ray, for example. And this is a tool. This is not that, but I think that you can more or less see the state of the components, the time of the components. Anything to?
Yeah, but that's a custom tool. I mean, it's not an official.
Yeah, I mean, this is not official, but once we have modules, I think that it wouldn't be difficult to implement one thing like that. And it would be helpful. For example, in our case, we miss an accelerator for this tick architecture because you always have to start from the beginning. And I think that KX is working in this with the database tool, this DB service that they are creating these days. And I don't know. I think that we have room now with the modules and with this direction to add more things and to create more layers. And also, I don't know if KX is working on that directly, but we as a community, we could help also.
Yeah, thank you.
Okay. So I think that's all. So thank you, Jesus. Yes, as two final notes. Okay. So first, I don't know if you are aware of Iverson. What is Iverson College? The Iverson College is a very selective conference based in Cambridge. So the best, almost the best developers of array programming languages such as KDB or APL, BQN, WIWA, among others, share their ideas and share their projects in this conference. So it's a selective conference. It's you can just go by invitation. Okay. So if anyone here, or anyone of the chat is interested in this, so please tell us. Okay, so that's the first thing. And the second note is for the new people here, please now stay in the networking, please present yourself, and we're happy to know you. So now let's have some drinks and food. So thank you everyone for coming. Okay. Another thing, we have some shirts, some KDB shirts, so please take if you want. They are in that table, okay? That's all.